In part C, we're dealing with the speed of the particle. And you have to recall that when you're working with the speed of a particle in vector-based functions, that the speed of the particle is given by the function speed is square root of dx dt quantity squared plus dy dt quantity squared. So we're going to need to enter that function, and we want to find out on the interval for time t greater than equal to 0, less than or equal to 4, at what point in that interval does the speed first reach 3.5. So we're going to come back to our calculator. We have dx dt and dy dt entered there. What we do need to do now is to find the square root of the square of the first function. So that's vars y vars function y1 squared. That is actually dx dt quantity squared plus vars y vars function y2 quantity squared, and that is actually dy dt quantity squared. And I'm going to turn off the previous function, and so that I only have my speed function in there, and I want to find out when that is first going to equal 3.5. So the way I'm going to do that is to also put in the function 3.5. Y is equal to 3.5, and what I want to do then is to look for the intersection, or the first intersection, of those two graphs in the time interval from 0 to 4. So I'm going to zoom, standard, and now with this particular case it's kind of hard to see what's going on. I would prefer to use a zoom box here, and I'm just going to move the cursor. You see that it started with the flashing cursor at the origin. I move it over a little bit. I need to hit enter, and I'm going to stretch out a box vertically and then horizontally across to where I think it at least includes the first intersection of them. Hit enter, and we can clearly see where the first intersection would be, and now I can use second calc intersect first curve, second curve, guess. Oops, hang on here. Alright, so what I'm assuming that happened there is that I'm not close enough to the point of intersection. So I'm going to try this one more time. Second calc intersect first curve, second curve, then I'm going to move close in to that suspected one, and that's it. I guess for some reason if you're not close enough to it, it couldn't find it, especially being that we had that whole open part of it to the left. So my answer is 2.226, rounding up to 3 decimal places. So I would say that the speed is 3.5 for the first time in t greater than or equal to 0, less than or equal to 4, at time t equals 2.226. And I don't think that we have any units here, so it's not important to put that in. So that's for part C. Finally, for part D, we're asked to find the total distance traveled by the particle. And the total distance traveled actually uses that speed function, and you're just going to take the integral of that between the 2 points t equals 0 to t equals 4. And it kind of makes sense if you think about it. If the speed and dt is a small change in time, if you take the speed at any time within t equals 0 to t equals 4, and then you multiply that by a small change in time, now you have a rate times a time, and that gives you a small change in distance. If you add up all those small changes in distance, you get the total distance traveled by the particle on time t equals 0 to t equals 4. So I'm just going to go back to the calculator. I already have that speed function in there. I'm going to turn off the 3.5 one, and I'm going to zoom standard again, and all I need to do now is second calc option number 7, lower limit 0, upper limit 4, and I get a value of 13.182 units.